Hey folks, in this video we're going to be looking at more intermolecular forces. Yay! 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 I'm so excited! Look, there's just a stray exclamation point. Let's get started. So in this video we're going to be looking at ion-dipole forces. And if you've been following these in order, you should have just seen that we looked at hydrogen bonding, which is weaker than our ion-dipole forces. And then in turn that is stronger than a regular dipole force, and that in turn is stronger than a London dispersion force. So we can see London dispersion forces are the weakest, followed by dipole forces, followed by hydrogen bonding. Let's just write bonding under there so it's not super confusing. And then our new strongest thing that we've looked at is ion-dipole forces. So what is an ion-dipole force? So an ion-dipole force we observe with ions and dipoles. Yeah. So let's look at an ion. Let's say we've got some Na plus, and you know what, we pretty much always see Na plus hooked up with its friend, who's slightly larger, Cl minus. So here we have an ion, and each of these has a charge, a full-blown charge. Before we were talking about partial charges, but this is a full charge of +1, and this is a -1 charge, and they are attracted to each other. And so if we were to throw in, let's throw in our good friend water. Water, we know, has a partial negative charge on it. So in addition to being attracted to this chlorine, this sodium, its positive charge is also going to be attracted to this partial negative. Now, which attraction do you think is stronger, from sodium to chlorine or sodium to the oxygen here? Take a second to think about that. Well, hopefully the fact that we describe this as a partial charge clues you into the fact that there's less charge here. So we've got one charge to one charge here and one charge to like something like half a charge or less there. This is going to be weaker than this because there are full-blown charges pulling on each other. Well, we have a partial charge pulling on the positive charge here. This is weaker than our ion-ion interaction. But ion-dipole forces and interactions are very important, particularly when something dissolves. So if we were to start putting lots of water molecules around this sodium, what would happen? So if I were to throw some sodium chloride in with a whole lot of water, which is the case when we dissolve sodium chloride in water, there's going to be a lot of water molecules that move in around this sodium. Now remember, this attraction of the sodium to each one of these individual water molecules is less than the attraction to this chlorine. But when you start building up a lot of partial negative charges around this full-blown sodium positive charge, that's going to make it easier for this chlorine to depart. And once this chlorine leaves, well, what's going to happen is more water molecules are immediately going to fill in that spot. And so now our sodium is completely surrounded by these water molecules. It is totally dissolved. All of the partial negative charges on these waters are helping to support this positive charge. And we'll see actually the opposite thing happening with our chlorine, where there are going to be positively charged hydrogens who will interact with its negative charge. So we can have a water molecule, and each of the hydrogens might be interacting with it to dissolve this chlorine ion. I'm not going to draw all of them. Chlorine, get back in your spot. But that is what happens. Either our partial positive charges on our dipole dissolve a negative or anion, or all of our negative partial charges on a dipole stabilize a positively charged ion. And so this is what happens when something dissolves. And so just to reiterate, this is a very strong dispersion force, or I'm sorry, intermolecular force. This is stronger than our stronger than London forces, stronger than dipole forces, stronger than hydrogen bonding. We're looking at our ion-dipole forces. And again, we are only really going to see these when something is being dissolved. Cool. So I hope you enjoyed that video on intermolecular forces. I hope you're having the best time of your life and can't wait for the last video in this series. Great, awesome, super duper, ta-ta.